Hello and welcome. Now we shall have a discussion on condensation polymerization. Polymerization is the process of synthesis of a polymer from monomer. It is of two types. These are addition and condensation polymerization. In another video, I have talked about addition polymerization. Now let us focus on condensation polymerization. This is a method of synthesis of polymers from bifunctional or polyfunctional monomers with the removal of small byproducts like H2O, NH3, etc. Now here the monomers are shown and the polymers that are formed from them is also shown. In case of diol and dicarboxylic acid monomer, the polymer that is obtained is polyester, diamine and dicarboxylic acid condense to give polyamide, diisocyanate and diol condense to give polyurethane. Now the small molecules that are eliminated like H2O, NH3, etc. For the first case, that is diol and dicarboxylic acid, the H2O will be eliminated to form the polyester, and for diamine and dicarboxylic acid, ammonia molecule will be eliminated to form a polyamide, and so on. Now we will study the steps for the formation of polyester. So one end of the diol will condense with one end of the carboxylic acid where H2O is eliminated and an ester linkage is formed. H from the hydroxylic acid group, hydroxyl group, and OH from the carboxylic acid group will combine to get element to combine to eliminate water molecule, and the ester linkage is formed. Now we have a free carboxylic acid end, and this will condense with the hydroxylic end of another diol, thereby one more ester linkage is formed. And now we have a hydroxylic end which is free, and so it will condense with the carboxylic acid end of the dicarboxylic acid to again form a ester linkage. So in this way, here we have now we have a carboxylic acid end free which will again combine with the diol, and this process will go on. That is, the monomers will add alternatively to increase the chain length of the polymer. Now here we have shown the process with the involvement of one hydroxylic end of the diol, but the other hydroxyl end also will participate in the reaction. And the repeat unit is shown which contains a ester linkage which is repeated n times. That is why this is termed as a polyester. Now here is one example of a commercial polyester, that is the terylene or polyethylene terephthalate. Now the monomers that has been used here is ethane 1,2-diol and benzene 1,4-dicarboxylic acid. There will be a removal of the water molecule, and thereby the repeat unit is shown over here. And this terylene also is known as the brand name Dacron, and it is a synthetic fiber that is used for making curtains, clothing, etc. And also this is used to make the plastic bottles, and in that case it is known as the PET. Now likewise, now we will describe about the polyamide formation, where the monomers are diamine and the dicarboxylic acid. Now the amine end will condense with the carboxylic acid end, and thereby the elimination of ammonia molecule will lead to the formation of the amide linkage. And again the carboxylic acid end is free, which will again combine with the amine end of another diamine, so that another amide linkage is formed. So in this way, alternatively, the diamines and dicarboxylic acids will go on adding, and hence the carbon, hence the polymeric chain will increase. And here we have shown the repeat unit of the polyamide. Now, here an example of a commercial polyamide is shown, which is the nylon 6,6, and the monomers that are involved is 1,6-diaminohexane and hexane 1,4-dioic acid, and they condense with the elimination of ammonia to form this repeat unit, which is repeated n times. Now, why the name is nylon 6,6? Because here 6 carbon atoms are present in the diamine and 6 carbon atoms are present in the dicarboxylic acid. From here, the nylon 6,6 name comes. Now, we all are very familiar with the use of nylon 6,6, which is used for making ropes, carpet, conveyor belt, parachute, uh, socks, and toothbrush bristles, and in many other cases also. Now, by far we have discussed about the copolymers, that is the polymer that are obtained from two different types of monomer. Now, we can also perform the condensation polymerization with the involvement of only one type of monomer, which will lead to a homomer. Now here one example is shown. Here the caprolactam will produce the nylon 6. And why it is nylon 6? Because 6 carbon is present in the repeat unit. That is why it is nylon 6. And the caprolactam has two functionalities which are suitable for undergoing the condensation, and so a homomer is resulted. So we have explained the condensation polymerization, and thank you very much for viewing and have a nice day.